everyone. Welcome back to Spring into Math 7. I'm Mrs. Campbell, and today we're going to be doing the third review for Chapter 3. Let's get started. Okay, so first of all, I wanted to take a quick review of how we solve two-step equations. And it's important that we have our terminology right. So let's take a look. We've got 3x plus 7, and I simply wanted to point out that those are both terms. 3x is a term and 7 is a term. The 3, and I'll highlight that for you, the 3 is the coefficient when it's next to the variable there, x. Okay, now also it's important to point out that this equation has two steps. It has multiplication and addition. Now because we're trying to solve for x or understand what our variable is, we're actually going to do the opposite or the inverse operations for multiplication and addition. And those would be to divide and to subtract. Okay, so to sum up, when we know all the numbers in an expression, we can solve with the order of operations. And that's on the left side, or my right side, of the graphic over here. Finding the answer when you know the problem, then you're going to follow the order of operations. First you multiply and divide, then you add and subtract. However, if you are trying to solve for a variable in an equation, you're going to do the opposite, or you're going to actually work backwards. We know the answer, so we use the order of operations in reverse or backwards. It's called inverse operations. So when we are finding the variable, when we know the answer, first we add and subtract, and then we multiply and divide. And here's an example of that. We have negative 2.7x minus 5 equals 16.6. We're going to do the inverse operation, which is to add 5 to both sides. And notice that we are adding before we're dividing. Okay, so now we have negative 2.7x equals 21.6. We're going to divide both sides by negative 2.7, and we come up with x equals negative 8. All right, this problem's a little bit longer, but if we break it up into two different sections, it's actually not so bad. Let's take a look at what I mean by that. The problem reads 1/2 times 8m plus 2 minus 2 times m plus 1 equals 17. And I'm going to break this up into two pieces. First, I'm going to do 1/2 times 8m plus 2. Okay, and I'm just going to leave the other side of the problem aside for a minute. Now the next thing I'm going to do is I'm going to distribute that 1/2 to the 8m and to the 2. So now I get 1/2 times 8m plus 1/2 times 2. I've used my distributive property. Okay, now I'm going to get common terms. I'm going to switch that 1/2 to the decimal 0.5. 0.5 times 8m, 0.5 times 2, and I'll add those two together. Now I'm going to get to common terms. That's what I got to common terms. Now I'm going to just basically do the math. 0.5 times 8m equals 4m. 0.5 times 2 equals 1. Okay, now I have moved this little part of the problem back to the remainder of the problem, the rest of the problem. Now let's use the distributive property on the other side of this problem. I've got negative 2m plus 1. Negative 2 times m plus 1. I will distribute my negative 2 to both of these. And I get negative 2 times m plus negative 2 times 1, which gives me negative 2m plus negative 2. And now this part of the problem will join the other. Now my problem reads 4m plus 1 minus 2m plus negative 2 equals 17. All right, for my next step, I have used the additive inverse. And what I've done basically is I've taken this negative 2m and turned it into a plus negative 2m. Or it's told me to subtract 2m, but I've changed it to plus a negative 2m. And it'll be easier for me to combine like terms that way, and I'll show you what I mean. My next step, I'm going to take this 4m and plus this, add this negative 2m, so I can combine the like terms to come up with 4m plus negative 2m equals 2m. And then I'll just bring the rest of my numbers down here. And now I have 2m plus 1 plus negative 2 equals 17. All right, do the math. 2m stays the same. 1 plus negative 2 is negative 1. Now I have 2m plus negative 1 equals 17. I'm going to add a -1 to both sides of the equal sign so I can isolate that variable. Now I've got 2m equals 18. Move my work up here. 2m equals 18. I'm going to divide both sides by 2. That's my inverse operation. My 2's cancel out, so now I have m equals 18 over 2. And I simply have to divide 18 by 2, and I get my answer, m equals 9. All right, let's try a word problem. And I'll highlight the information. It's always a good idea to circle or highlight the numbers or the key information that you find in a word problem. All right, Randy spent $89.98 on a phone. After he bought it, he had $27.32 left. How much money did he have before he bought the phone? Now, in our word model, we have the original amount minus the phone cost equals the amount that Randy had left. If we wanted to put this into an algebra model, our variable would be x. That's what we don't know, his original amount of money. Minus $89.98 equals $27.32. That's the information that we do have. Okay, x minus $89.98 equals $27.32. We're going to add $89.98 to both sides of the equal sign, and we get x equals $117.30. So now we know Randy had $117.30 before he bought the phone. All right, last word problem. On Wednesday, Harry sold 3 times as many bars of chocolate as he did on Tuesday. On Thursday, he sold 5 times as many bars as on Tuesday. In all, he sold 90 bars of chocolate. Find the number of bars he sold each day. And we're going to let C equal the bars that he sold on Tuesday. So we have the number that he sold in total, which is 90. So basically, we can write this in word form, excuse me, Tuesday plus Wednesday plus Thursday equals 90. Okay, so what he sold on each of those days added together equals 90. Tuesday we'll say is C. We know Wednesday he sold 3 times as many as he did on Tuesday, so we can show that as 3C. Thursday 5 times as many as Tuesday, so we can show that as 5C. And we have the equation C plus 3C plus 5C equals 90. I'm going to combine all my like terms. I have all these C's, 1 plus 3 plus 5C. I have 9C equals 90. Now I will divide both sides by 9. My 9's will cancel out. And C equals 10. And remember, C is Tuesday. So that tells us that Harry sold 10 on Tuesday. But that's not the whole question. The question asks us to find the number of bars he sold each day. So we know that on Wednesday he sold 3 times as many. So it's 3 times 10. 30. And on Thursday, he sold 5 times as many as he did on Tuesday, so that would be 5C. So Tuesday 10, Wednesday 30, and Thursday 50. And that's how many chocolate bars altogether total 90. All right, everyone, that just about wraps up this review. Thanks so much for joining us, and we'll see you next time.